Okay, so here's a problem that came across my desk. We have a quadratic equation here, x squared minus 8x minus 4 equals 5. A is 1 here. And let's go ahead and do this one with the quadratic formula. I have a previous video using the factoring method. We'll end up probably doing a lot of these over time. So let's talk about that quadratic formula. But first, we're going to go ahead and do the step one, which is to put it in standard form. And that is to move all of the terms to the left of the equation in descending order. So I'm going to subtract 5 from both sides. And that's going to give me x squared minus 8x minus 9 equals 0. Okay, and let's just take the moment to point out our quadratic coefficient. When there's no coefficient written, it's 1. We're going to call that A. And our linear coefficient, I should have given myself more room here, -8, we're going to call that B. And our constant term, -9, we're going to call that C. Hopefully that shows up there. A, B, and C, the three numbers in the equation after it's in standard form. And those are the numbers that we use for the quadratic formula. And I'm sorry to say, you do need to memorize this formula. And it's a doozy. So we've got x equals the opposite of b plus or minus radical b squared minus 4ac all over 2a. And it's good to understand the quadratic formula. The part that's under the radical, b squared minus 4ac, is called the discriminant. I'm not going to really do a whole lesson here. I'm just trying to keep it brief. And the rest of the quadratic formula, the -b over 2a, is the vertex. And we'll use that on other problems in the future. But I do want to start when I'm solving a quadratic equation in standard form. I want to start with the discriminant. So I've got my a, b, and c, and I'm going to put them into the discriminant first. I'm going to do the discriminant first, which again is b squared minus 4ac. Okay, so if b is -8, then b squared is 64. -4 times a, which is 1, and times c, which is -9, makes positive 36. And 64 plus 36 makes 100. And this, I'm going to circle this. This is not my answer or my solution. This is my discriminant. And it tells me a few things. Because this one is positive, it tells me that this quadratic equation will have two real solutions. And in this case, this discriminant is also a perfect square. 10 squared is 100. And so that tells me that this quadratic equation is factorable. I could solve it with the factoring method, which is also to say that my two real solutions will also be rational. So that may not make a whole lot of sense to everybody out there, but since I've already done this part of the quadratic formula, which is 100, I can go ahead and do the rest, right? So I'm going to have x equals the opposite of b, would be positive 8, and then plus or minus the square root of my discriminant. The square root of 100 is 10, so that's where it was really helpful that my discriminant turned out to be a perfect square. And then all over 2 times a. If a is 1, 2 times a is simply 2. Now I can find my two solutions. I'm going to have two real solutions. My discriminant told me that. By the way, there are kind of always two solutions, but we'll talk about different kinds, including double roots. I can do the 8 minus 10 and divide it by 2, or 8 plus 10 divided by 2. That's relatively simple to do. There's no reason not to. But I do want to show you that we can also reduce this. Since all three of these numbers are divisible by 2, we can reduce them all together. We can only do that if we can reduce them all together. So this is kind of a bonus step. You don't really have to do the reducing first. You can do the reducing last, but you may as well because you're going to have to reduce it one way or another. So that now has reduced to 4 plus or minus 5. right? A denominator of 1 we don't really need to write. It's just understood. And so 4 minus 5 is -1, and 4 plus 5 is 9. And so those are the two real rational solutions that our discriminant hinted at. Those are the two real rational solutions for this quadratic equation. Or in other words, either one of these numbers, when substituted for x, will make this original equation true. And technically, I should go ahead and substitute them both in and check that, but I'm not going to take the time to do that because I'm lazy. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.